All right, guys, hello and welcome to another physics video lecture. Today we are going to be talking about the work-energy theorem, right? Get pumped. Okay, so in order to understand this theorem, we have to go back and look at two concepts that we've already looked at. The first of which is work, right? So what is work? Work is a concept that you probably have an idea of about jobs and careers, but in physics, work is very simple. Work is when a force is applied to an object and that object moves, okay? The equation we've seen before, it's really simple. It is simply work equals a force times a distance. The bigger the force, the bigger the distance, the bigger the work. They're both directly related. We measure work in joules. All right, so we've seen this before. The second equation that we need to go back and revisit is kinetic energy, right? This is the work-energy theorem. Kinetic energy, as I'm sure you remember, is the energy of motion. What that means is that any object that has velocity, any object that is moving, has kinetic energy, okay? All objects in motion have speed, they all have velocity. Right? And this is our equation that we've seen many times now. Kinetic energy equals 1/2 times the mass times the velocity squared. The bigger the mass, the bigger the velocity, the bigger the kinetic energy. Okay? Now, today we're going to take these two equations and we're going to put them together in something called the work-energy theorem. All right, so what's the work-energy theorem? Oh, sorry, I should go back here. We also measure kinetic energy in joules, which is the same as work. And this is very important. Because as we're going to see today, okay, the work-energy theorem tells us this. When you change the motion of an object, meaning when you change its kinetic energy, okay, if you cause an object that is at rest to speed up, or if you cause an object that is moving to slow down, you're changing its motion. You're changing its kinetic energy. And in order to do that, you have to do work. Right? So the big takeaway from today, and this equation always gets sort of lost in the mix because it looks weird, but work equals a change in kinetic energy. And the reason I showed you those last two equations is because this is what you get on your equation sheet. But the way that you use it is you have to go back. So work means a force times a distance equals a change in kinetic energy. Remember, that's what this triangle means. This is the Greek letter delta, and whenever you see this triangle, it means that something is changing. If your kinetic energy changes, well, what's changing? Well, kinetic energy equals 1/2 the mass times the velocity. Okay, 1/2 doesn't change, and the mass doesn't change. The velocity changes. So in order to see this, we always have to go final minus initial. Always look back at your acceleration equation. All of these equations, it's always final minus initial. But these velocities are squared, so it's final velocity squared minus initial velocity squared, okay? Whenever you have a change in kinetic energy, work has to be done. You have to use force to either speed up or slow down the object, right? Forces cause acceleration, okay? Now, these are all the notes for today. Really, these are the only new notes. If you don't have the old notes on work and kinetic energy, write those down. But we're going to jump right in and look at some equations here. All right? So, here we go. There's going to be a theme. I think we're all about cars today. Steps are still the same. We write down what we know. Here's what we know. A 2,400 kilogram car. So we got that, 2,400 kilograms. So we know our mass equals 2,400 kilograms. Accelerates from 3 meters per second to 10 meters per second. Well, here is our initial velocity, and here's our final velocity. So we're going to write those down. Our starting velocity is 3 meters per second. Our final velocity is 10 meters per second. All right? How much work does the engine do? So we're just looking for how much work is done. All right. So this is important here because there's different ways to write this equation down. In this case, we're going to start at the top. So our equation is work equals a change in kinetic energy. Okay? Now we're looking for work. So I'm just going to bring the work down here. We don't have to worry about force and distance because we're just looking for work. but we have a change in kinetic energy. So we do have to write this part down. This part is 1/2 times the mass, and our velocity here is changing. So it's the final velocity squared minus the initial velocity squared. All right? Okay, so let's plug our numbers in. So here we have work equals, okay, 0.5. Remember, 1/2, I always write as 0.5. It's way easier to put in your calculator, trust me. Times our mass, which is 2,400, times our final velocity, which is 10 squared, minus our initial velocity, which is 3 squared. Okay, all right there, looking good. Now look at this problem. We have our W, what we're looking for, our variable, all by itself. So all we have to do is put this in our calculator. All right, so bring up my calculator. Perfect. You know, it should see everything. All right, so we're going to put it in just like we see it. So we're going to put in 0.5 times 2,400 times, and this is important, parentheses, 10 squared minus 3 squared. We're going to close that parentheses. And my answer is all the way over here, but I'm going to hit enter to get that answer. And that answer is 109,200. So the work done here is 109,200 joules. Okay? The work done equals the change in kinetic energy. Now, you could find the first kinetic energy and the second kinetic energy and subtract them, but this is just a little bit faster. Okay? Step number 1. You with me? Pretty easy? Okay. Let's look at problem number 2. Clear this out. Go back. All right. So again, take a shot at this yourself, write them down, pause the video, see if you can get this one by yourself. Okay? You got an answer? Let's see what you got. So we have a 1,300 kilogram car this time. And it's doing 50,000 joules of work. So I know my work. My work is 50,000 joules. If it starts from rest, you remember that from last year? That means our initial velocity is 0 meters per second. How fast does it end up going? Well, that is our final velocity. That's what we're looking for here. All right, so this is where it becomes fun. All right, so remember, our equation here again is always going to be work equals a change in kinetic energy. Okay, again, we know what work is, so we're just trying to find the change in kinetic energy. So like I said, we're going to write down work equals, and again, you could write it down like this, 1/2 mass times the final velocity squared times 1/2 mass times the initial velocity squared. You could do this. This just makes your math a lot longer and harder, especially for a question like this. So instead, we're going to take the 1/2 and the mass and put it outside. If you remember your algebra, to look like this. 1/2 mass times final velocity squared minus initial velocity squared. All right, so we plug our numbers in. Okay, work is 50,000. That's helpful. And that equals 0.5 times our mass, which is 1,300. Times our final velocity squared minus our initial velocity squared, which is 0, minus 0 squared. Well, if you remember anything minus 0 is 0. So we're just going to get rid of that 0 squared. Okay, we don't care about that initial velocity here. It's 0. All right, so again, we have 1/2 times 1,300. So we do that math first, because remember, what we're after here is this final velocity, okay, by itself, okay? So we go to our calculator, or calculator, as I like to call it. Where is this? There we go. There we go. Okay, so we have 0.5 times 1,300, and that gives us, enter, answer, 650. So I'm going to bring this down. So now I have 50,000 equals 650 times VF squared, final velocity squared. I still want the final velocity by itself, so I got to move 650. This is multiplication, so we do the opposite. We're going to divide by 650. Whatever you do to that side, you do to this side, right? 650 divided by 650 is 1. Okay, and we got 50,000. So again, watch this. I'm going to go clear. So I'm going to go 50,000, 5, 0, 1, 2, 3. 50,000 divided by, isn't that a cool trick? I hit the answer button. And that gives me my answer here, which is 76.9. All right, very nice. So now I have, Alex, right? 76.9 equals VF squared. Now, remember, this is not our answer. We're trying to get to VF by itself, so we got to get rid of that square. So we got to do the opposite of squaring, just taking the square root. Again, it's just going through the same steps we've always done. So all I got to do now is hit enter, square root, and if I just hit the answer button, boing, that number comes right there. And this gives me my answer, which is 8.77, or we're going to round up and say that my final velocity here is 8.8 meters per second. Isn't that awesome? We just figured out how fast that thing's going. Did you get 8.8? If you did, good job. If not, write this down. Go through it. Go back in the video. Take the video back. Okay? Whenever I'm learning stuff, and I use YouTube videos to learn stuff all the time, whether it's cooking or things I'm trying to learn how to play on guitar or how to fix something in my house, I'm watching the video, I go back. I watch it, I go back. Watch, go back. Trust me on this. Okay? Do it till you get it. Let's do another one. All right, we got a 20,000 kilogram car. Let's write this down. We got mass equals 20, what do you say, Mr. Norris? 2,000 kilograms. It comes to a stop. Okay, very good. So it comes to a stop. So what that means is that its final velocity is going to be 0 meters per second. Okay? This requires, and this symbol should be down here, a negative amount of work. Why is it negative? Because it slows down. If you slow down, you're doing negative work, right? Why is that? Because I'm driving, when I slow down, I hit my brakes, and the thing that happens is my wheels stop, so now I have friction slowing me down, right? The tires are rubbing against the road. Well, which way does friction point? Backwards. Which way am I moving still? Forwards. The force is going in the opposite direction, so it's negative. So the work being done here is actually negative, and this is like a lot of work. 1, 2, 3, 4, 5. This is 400,000 joules, okay? How fast was it going initially? Means we're looking for VI. Okay. Pause the video, see if you can get this one. It's very similar to the last one. Okay? So again, work equals a change in kinetic energy. We know the work. We're looking for the change in kinetic energy. So I'm going to put the work here is 400,000. And that equals 1/2 times the mass, which is 2,000, times VF squared minus VI squared. One thing I'm missing. This is negative. I forgot this is negative work. Very, very, very important. Okay? Okay, so what to do now? First step, I'm going to multiply 1/2 by 2,000. Hopefully you know that half of 2,000 is actually 1,000, okay? So 1,000, and I put that there, but you know me, put that at 0.5. Okay, so this now equal to negative 400,000 is equal to 1,000 times, I didn't put my numbers in here. What are you doing, Mr. Norris? We're looking for our initial velocity, but we know our final velocity was 0 squared, right? It stopped. What am I doing? That's your final velocity. I had it right. So now we have 0 squared minus the initial velocity. 0 squared goes away, so all I have is a negative initial velocity squared. More on that in a second. So I want VI by itself. Same old soup as before. Okay? This is multiplication. So I'm going to divide by 1,000, divide by 1,000. 1,000 divided by 1,000 is 1. Okay? And 400,000 divided by 1,000, I know you can put this in the calculator, it would go 1, 2, 3, gives me, okay, I knock off 3 zeros, and now I have negative 400 equals negative VI squared. Okay, so I still want VI by itself, right? Everybody see what I'm doing here? Now the trick here is these are both negative, and if you put the square root of a negative number in a calculator, it'll give you an error. Can't take square roots of negatives. But this is negative and this is negative. So if I divide both sides by -1, which I can do, that makes my negatives go away. So if they're both negative, just divide both sides by -1, and now they're both positive. Now I just have to get rid of this square, so I take the square root. Okay. If I go to my calculator here, the square root of 400. Yep. So again, if you don't believe me, go up here. So I'll do this all at once. What's this? 0.5 times 2,000 gives me 1,000. I'm going to take 400,000, 5 zeros. I'm going to divide that by my answer, which was 1,000. That gives me 400. And I'm going to take the square root of my answer, which is 400. And that gives me my answer, which is 20. The square root of 400 is 20. Isn't that fun? Awesome. Okay, did you get 20 meters per second? That's how fast we were going when we started. All right, I think we have one more. Let's just do one more. Okay. Last but not least, how much force is needed to move a 1,250 kilogram truck from 20 meters per second to 25 meters per second? Let's see. Okay, so we have our mass, which is 1,250 kilograms. Our velocity, our initial velocity is 20 meters per second to our final velocity, which is 25 meters per second. Okay, and our distance here is 500 meters. We are looking for how much force. Now, this is where this comes into play. Okay, how much force is needed? All right, so what we need to do is we are going to use both sides of this equation. So work equals a change in kinetic energy. Okay, it's final kinetic energy minus initial kinetic energy. Okay, our work here is what we're looking for. So we need to find our work. Force times distance equals 1/2 times the mass, final velocity squared minus initial velocity squared. Okay? And all you got to do here is plug your numbers in. So we're looking for force, so that stays the same. We're going to multiply that by our distance, which is 500. That equals 0.5 times our mass, which is 1,250, times our final velocity squared, which is 25 squared, minus our initial velocity squared, which is 20 squared. It's a lot of writing, and this looks complicated, but watch how quickly we simplify this down. All we have here is numbers. So all we got to do here is put this in our calculator, right? So I get my calculator back on screen. It shouldn't be easier than that. Here we go. Clear everything out. Okay. Punch our numbers in. 0.5 times 1,250 times, parentheses, very important, 25 squared minus 20 squared. See how easy that was? Close parentheses. I hit enter, I hit answer, and that gives me my answer. So this side of the equation over here, we already figured out. We have 140,625 joules, and that equals my force times 500. See how quickly that became really easy? We're looking for force. Boom. Okay. So we need to get the F by itself. This is multiplication. So we divide both sides. I take my answer here. I hit divided by 500. Enter. Answer. My answer here is 281.25 newtons. We haven't seen newtons in a while. That's our force. Force equals 281. We'll just keep it there. Newtons. Okay? Now, you may see questions that are easier than they look. If a question gives you two kinetic energies, if it says that you have an initial kinetic energy of 500 joules and a final kinetic energy of 600 joules, and it wants to know the work done, okay? This is easier than it looks. I didn't do a problem like this because look, work equals a change in kinetic energy, which is really the final kinetic energy minus the initial kinetic energy. So if you know these, you can just plug them in, okay? Okay, well this one would be work is equal to 600 minus 500. 600 minus 500 gives us a work is 100 joules. So if it just gives you initial and final, use this equation right here. Work equals the final kinetic energy minus the initial kinetic energy. So that one's going to be simpler than it is, or than you may think it is. Now, I had 2 more problems on here, one of which is they're both bonus problems, so if you want to go through the PowerPoint, solve them, send me your answers, I might even toss you some extra credit, okay? And it'll definitely help your brain out. Looks like a lot of work, but we've been building up to this, and it's really not that difficult. It's the same moves over and over again. Make a chart, write down your equation, follow the math, and it will set you free. All right, guys, I'm actually going to wait to erase that. If you guys have any questions, you can always email me, all right? And have a great day. I'll catch y'all soon. Be good.